Hello and welcome back. It's been several months ago since I made my last video, so I thought maybe it's time again to show something I have been working on. Actually, it's more than that. I've been working on several electronic designs lately, and one of them is this card. It's just a simple programming interface for Microchip PIC chips, but it is unique in one way. I mean, you can buy several generic PIC programmers, but all of them I have seen has a disadvantage, and that is whenever you change PIC, you program, for example, an 8-pin type or 40-pin type at one time, 28-pin or 20-pin another time. You have to shift several jumpers, and I hate to do that every time I change. So I thought I will design one which will be as generic as I could make it. And it also must be simple. So this was my goal. And I came up with this design where I can plug in the PIC programmer to the left or to the right, depending on which type of PIC I want to program. And by doing that, I don't have to shift any jumpers. It made it very easy. It makes it very easy to program PICs. I also thought that I will use it not only for programming, but also for developing and being able to connect the PIC to a developer board or a breadboard, call it whatever you like. So I decided to have connections on the left and on the right side of the card, depending on which PIC, which type of PIC I'm having inserted in the sockets. All 40 and all 20 pins are connectable to a breadboard. So this is the way it looks. I think it turned out to be quite nice, and I know I will be using it all the time. And actually I assembled two of them to be used as soon as possible, and this is how it looks like when it's assembled and with a 40-pin PIC inserted in the socket. For this short demonstration, I am just using 16F877A PIC and some firmware I programmed for another project, which I'm not going to discuss in this video at the moment. For example, if I am using this PICkit programmer software for copying a PIC, then I can just insert it and set the type, and then just click on read, and then it will of course read everything. And as you can see, reading means the LEDs are flashing. And that was the idea. I wanted to have some kind of indication, so I also designed 4 LEDs are for this socket and 4 for the other. It's not necessary for the functioning, but I found it useful. For the design I'm using EasyEDA, and I have been using it for quite a while, and I find it quite very useful, easy to design your own parts if you want to, or your own footprint if you are missing something, or you wish to change a footprint of another part. As you can see, these are the 4 LEDs, and as you can see, there are no drivers for the LED, so they are directly driven from the actual pins of the PIC, which means that if you are going to copy my design, then you have to be careful. It's not suitable for every kind of design, but if you have enough power, then the PICs can drive the LEDs if you are using high intensity, low current LEDs like I am using. So that's it. Once the circuit design is done, you can easily switch to the design of the actual PCB layout part and generate automatically the route. It has a quite efficient auto router, although with a more complicated design it takes a while, but it doesn't matter if it's not critical. And then after that, just a few clicks, and then you can order the PCB. So this is it. This is the way I am using it. I mean, I prefer doing the programming at the PC isolated from the development board I am working with, because if something is wrong with the development board, then it might fry my PC, and I don't want to do that. Once I'm ready with the firmware development of the chip, I just move over the chip to the space where I am working with the actual electronics development, and then of course wire it up as necessary before powering up everything, and then I just power up whatever I'm working on, and then do all the testings I want to do. During when the device is plugged into the electronics, these LEDs flash more or less randomly or light up, whatever it is done in the firmware. And in this case, there are 2 yellow LEDs indicating the VDD, and the white LED indicating the program data, but it doesn't really matter. And if I start the testing, there can be other LEDs flashing also or lighting up, but these LEDs are now not used at all, because it's just not important which one is lit up. What is important is what's happening here, and if the firmware is doing what I expect it to do. And in this case, since it's already been tested, I know it works as I wanted it to work. So it's exactly right as I wanted. So that's it for now. I mean, it's really very, very simple. You just wire up VPP, VDD, VSS, and program that data and program clock to the right pin for each type of PIC you are planning to use. And in my case, I selected all of them I have. I have a whole box of PICs of different sizes and ages, and I like to use them. They are saving a lot of logic chips and a lot of extra wiring. If you copy this, I think you will be happy to use it also, because I find it very functional. So that's it for now. Thank you very much for watching, and goodbye.